So as you can see, I'm off to a good morning here. I have the motor ready. We are going to get tearing on this thing and get it all ripped up. We want to see what went wrong, where the problems are, and we'll go from there. I will just start getting into it. Before I pull this head off, I want to go over this. For those who do this, make sure that you loosen the head bolts in a manner that's reverse of a star pattern, similar to that of what you do for the Torx spec when you're actually torquing them down. You know, start in the middle, work out. We'll go backwards. Start at the outside, work in. And I do that just a little bit with the ratchet, and then I use the impact once they're loose to just pull them out, because obviously they're loose already. But that is for the sake of trying to prevent warpage as much as possible, because the less warpage you have, the less milling is required. I'm not sure what the compression ratio is currently on this thing, what the CCs are on the head. I know that the heads have been off before, so I'm not sure where it's at, and I want to make sure that I end up with the most material to work with so I can set it accordingly to what I need to set it to. Okay, so this is the side with the failure. This side, I can see it's wet with oil. The rest of them are fairly clean. This one's a little bit wet, but this one's definitely wet with oil. And it's got more deposits on the intake valve. Oops, there's a dowel there. See that lineup dowel stuck in the head, or the head gasket? Make sure you don't lose those. Okay, so you're about to see where the failure is on this motor and where the noise is probably coming from. I say probably because it could be from something other than where I'm about to point it out, but most likely it is from that. See the little dents in there? Now, if you look, see how there's a bunch of dents right here, okay? Right in this little area. And then there's also a bunch of damage right in this area. Now what looks like happened, which there is another thing I'm going to talk about that's bothering me, but what looks like happened here is something got into the intake, it came through the intake, into the intake valve, and then dropped right over here, beat it up a little bit, and then came down, and then beat this up, and then eventually flew out the exhaust and out the tailpipe. So if you look closely here, see all that damage there? Right here, this little section is pushing against the cylinder wall. And you can see that because if you look closely at the cylinder wall, see if I can get it, see the score marks going up and down the cylinder right where that lines up to. So that, I believe, right there is where that squawk is coming from. It's rubbing up against here dry and squeaking because it's glazed over the cylinder. Oh, I don't know if you can hear that, but see. Hear how it's smooth over here? This whole area is really rough, especially compared to over here where it sounds smooth. So the cylinder wall has some scratching in it. I can barely see the scratching, to be honest, but it might just be that glazed over. Now it does have a couple spots that are really nasty. Right here. It's a really nasty spot. Then right here, there's a pretty nasty spot. Now, this is above the second ring. This is where the top ring is. And these are right at the top ring. So, this cylinder definitely has to be worked out to try and get it the best seal possible. Would it work like this? Fine, sure, whatever, it would. But I can't leave it like that. And there's a solid reason for that. The other cylinders are also damaged as well. So I'll move on to the next one. See this one here? It actually has even worse scoring than its neighbor with the damage, the mechanical dings. Now you notice this one does not have any damage, and there's a little bit of like a Scotch-Brite pad there, not much. But I'm gonna go back to this one now that I showed you that. And here's the part that concerns me. You see Scotch-Brite, Scotch wheel pads of somebody hitting this with a whiz wheel. That disturbs me a little bit. You shouldn't have to clean pistons off with a whiz wheel. Let's see here. This one has no markings whatsoever. I don't know about the cylinder bore. Let's check the other cylinders that are down. See, that one's got some nasty scoring. This one actually looks pretty good. So this motor is just worn out. Just plain and simply worn out. So I will get it torn apart the rest of the way, and we will continue and see what we find for other damage. There may be more damage down below. Well. We have a interesting scenario that I have not run across yet, and it involves a lifter. I can normally pull all these lifters out, okay? I can just grab them, pull them out, and it hardly takes any force whatsoever. This lifter, which is the exhaust lifter on cylinder 3. So, cylinder 3 exhaust lifter is stuck. I mean, it is like really in there. In fact, I can see his cam. I think I see a lobe that's damaged. Ouch. Oh, I pinched my finger good. This lifter is really stuck in here. It's probably not a good idea. Don't try this at home. So I do in fact see a damaged lobe. That means this guy's going to need a camshaft. He's also going to need lifters. And I don't know what I'm going to do about this lifter. I don't know if there's enough room to push it through the other side or not. But if I pull it this way, it's going to damage the bore, the lifter bore, really badly. So I don't want to pull it any further. I put a little bit too much effort on it already to try and get it as high as possible. I'm in hopes that I can push it through. At this point, I'm just going to continue taking the rest of the motor apart and hope that that it doesn't make the block need a bunch of lifter bore repair. Just to give you an idea, watch how easy it is for me to pull these out. But every single one of these has some sort of buildup on the surface of the roller, some worse than others. And in fact, there's a cam lobe that is worn out on this side. So cylinder number 3 and cylinder number 5 both have an exhaust lifter that has worn badly into the cam. Here is the lifter that did come out. That was on cylinder number 5. Oh, see that right there? It's a flat spot. So his noise is actually most likely coming from these lifters that are just totally screwed up. Stock GM bolt works, sure, but I highly recommend an ARP balancer bolt, especially if you have an aftermarket balancer like this. Oh, that's not good. Somebody has left a broken Torx bit in one of the holes, and all the Torx holes are damaged on the rest of them. I've never welded on a balancer before. This might be the first time I might have to weld on a balancer. Problem is it's fluid filled. Awesome. So this thing is literally unscrewing. I barely even squeezed with the pliers and it came loose. I was literally positioning myself so I could squeeze and see if I could get it loose, expecting to grab a wrench, and this thing is just coming right out, no problem. So, apparently that's how you get those things out of these. I'm a little concerned welding on this because this has fluid in it. I am going to suggest a rebuild, and it's going to take me some time to get all these things out of here. So I'm going to just keep going on it. Hopefully I got enough gas. I'm low on argon. Hopefully I have enough gas to do the job, but now I know I can get it apart. So yeah, that was awesome. So I will not be leaving any of the bolts in there. I'm going to take them all out because I was able to just grab the welding knob that I welded on there and it came right out. I mean, that's awesome. That is so awesome. I am excited to try this on a few more just for fun. It's actually kind of entertaining doing this. It comes out so nice and easy. I'm just having way too much fun with this now. I didn't expect that. I thought this was going to be a nightmare. I spent way too much time on the first one, not thinking it would come out so easy, but now I'm glad I tried that because I'll just do this from now on if I have trouble with this. I've had trouble with these before in the past. A lot of times people screw them up, or even I've had trouble just getting them off even when they're torqued properly. They get really on there sometimes, and it's unfortunate, but it's not a big deal apparently anymore. I just got to find replacement bolts. Aww, that one's not as easy. Let's try another one. That's the one with the Torx bit stuck in it. Okay, I think I know what it is. So the one with the Torx bit, I did not heat up as much initially. And it's simply because the Torx bit was in the way. These ones, I'm heating it up so much that I'm melting it into the hole for where the Torx bit would go, and then I'm filling it in with the welding rod, so it creates a lot more heat down further in the bolt. And that's the saving grace there. So I am going to go ahead and get this thing pulled. I got my tool here to do the job, to get this off of here. Now, these aftermarket, they are usually extremely tight, and I mean like bend your original puller tight. The snap-on one that I have can do it usually, but I feel like I'm gonna bend that too. So I made my own puller. It's a piece of aluminum plate, and it's thick. It's like an inch and a quarter thick. And I built this specifically for these balancers. There's lots of metal in the bottom of this pan. But it's probably steel, since this guy does not have a magnet on the drain plug, and since the cam is chewing itself up. Thought they have the moment of truth as to whether or not this cam will slip out of there with that lifter that's stuck. Oh, I got it. I must have moved it just enough. The battery died on the camera, unfortunately, so hopefully you didn't miss too much footage. But we have the camshaft out now. It took a bit of finesse. I had to beat the lifter down from the underside of the motor. But you can see the damage right there. Just got a nasty groove worn into it. This one was starting to pit and do it. We have another one here. This one's looking pretty nasty. At this one, a bunch of pitting and nastiness going on. There goes my phone. But yeah, we got the camshaft out. So I'm sure you've noticed that I've been marking every rod and checking every bearing, just taking a look at everything. And I've been doing that to just compare what's going on with the motor, and the marking of them is for the sake of just in case we reuse these rods. Now, I'm not sure what we're going to do with this build in the end, but it's not going to be a crazy build, I know that much. So if we can reuse the rods, we're going to. If we can't reuse the rods, then we'll have to get something new, but that'll depend on several different things. This just so happens to be the damaged piston. Okay, so you see all the dings there. Now, if we look at this side, okay, you can see this is where the ding is. Okay, now I want to point something out. This ring, this piston ring here, like this one, this is the second ring. Okay, I can spin the second ring, no problem. Okay, now if I go to this top ring, it won't spin. It's stuck. So if I grab this ring with intent to remove it, okay, right there, I can't get it out of the slot. It's caught in that slot right now. So it's unable to seal and do its job. Let's see if I can get the other side maybe. Ooh, I got it. I think I cut my finger open, but I got it. It was definitely stuck. Now I'll go ahead and show you guys what it's like when it's, or where it's stuck. So you take this thing, and you can see the damaged area right here, okay? And I rub it, and it stops right there. So I'm in the groove, and I'm just sliding it across, and it stops right there. You can roll over top of it, and then sinks down right after it. See how that does that? So this ringland is pinched tight. Look at that! I got that son of a gun out of there. Alright, so let's take a look and see what kind of damage has been done to everything. Aha, I see. I see why it wouldn't come out of there. Yeah, there's no way I was getting that out of the top. No way. Boy, I'm glad they left me enough room to get it out at the bottom. If I would have tried forcing that out of the top, I would have been screwed. This is new to me. I have never seen this one happen. Maybe any of you have. Anybody who watches that's just can't get enough mechanical work or can't get enough LS work and you do it yourself. Maybe you guys could chime in. But check this out. See that? That pin for the bearing on the roller is actually coming out. It's way in there and it's actually coming out. Now I try and pull that through the lifter bore. Ha! Yeah, right. So look how chewed up that thing is. Oh my goodness. All kinds of chewy. Chewy, chewy, bubblegum chewy. That is some hard bubblegum. I would not want to chew steel for bubblegum. Alright, let's see here. Oh, I can actually spin that pin. I wonder if I can get it out of there quick just to get a look at how bad that really is. Okay, so it is just a plain old press fit, it looks like. That's what it's supposed to be. You know, it actually looks like it was rubbing against something. Ooh, oh no. Oh no. Oh, ick. Ick, ick, ick. There's the tick that he heard. Oh my gosh. That pin that was coming out of that lifter was bashing into the block. That pin was slamming into the block. It left a huge mark in that lifter bore. Alright, so here is a good lifter bore. You can see it is clean and true all the way around, right? Here's another one. Clean and true all the way around. Now, here is the bad lifter bore. We'll shine the light on it. Yeah. Notice something? There is a huge chunk missing out of that. Now, the one good thing, the one saving grace here, is if you notice, the oil galley is right there, okay? That oil galley is the important part. And there is a very large distance between the oil galley and that nasty groove. So what I have to do is I have to figure out if that distance is big enough for this lifter and its oil galley spot. Now you can see the little hole here, right? This is up at the top. Another one here. Now that is where the oil is fed into. However, this slot right here is where the oil galley rides. So as this thing goes up and down in that hole, if this part, this open area, drops below that groove, it is going to cause a serious problem because the oil pressure will drop as soon as it comes down to that. So this might need a new lifter bore machined into it. I am going to have to see, maybe talk with the machine shop. I'll have to do some research and figure out what's going on there. So that is interesting. We will call this a wrap for this video. If you like what you see, make sure to watch the next episode. The next episode will be more in the realm of running parts around at the beginning, and then we will figure out what we need to do with that lifter bore. We will also be tearing down the rest of it, so we'll see what the crank bearings look like, and that'll probably be pretty much it. I mean, it'll basically be doing the parts, but we'll see what else we can find. I might pull the heads apart. We'll find out. We'll see what happens. Stay tuned and watch the next episode. Like, share, subscribe. Make sure to hit the notification bell if you want to see the next episode pop up on your news feed. Thank you for watching.